Right, here we go with 4.2, part 2, and this is the rational roots theorem. And so the rational roots theorem is going to provide you a list of potential zeros or roots if the problem doesn't allow you to find one with your TI, or if the problem doesn't give you that, say, x minus 2 is a factor, x plus 3 is a factor. If you just have to come up with your zeros on your own instead of all the numbers in the world, an infinite amount of numbers, the rational root theorem is going to give us a list. Okay, so the rational root theorem says the possible rational roots of a polynomial can be found by using the rational roots theorem. Okay. So rational sounds kind of scary, but it's not. It just means that's going to be your integers or your fractions. So if root 3 is a root, the rational roots theorem won't find root 3. It won't find your imaginary solutions. It's only going to find integers or fractions. That's what that word rational means. It basically means anything that can be written in a fraction. And an integer, of course, can be written as a fraction over 1. Okay, so let's say we have some, polynomial. All we care about is the leading term, a to the xn, plus dot, 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 plus the constant. All we care about is the leading term and the constant. All right, and so we introduced these two new letters, P and Q. And P, we're just going to take all the factors of the constant and call that P. As for Q, that's going to be all the factors of the leading coefficient. And we can build a list from these two. We can build a list from these two lists, leading, where am I, coefficient. Okay, then the possible rational roots possible, so we're going to have to test them because they're just going to be a list and they're going to be possible rational roots. We're going to have to test them. Are going to come from these possible combinations, so this list. And basically the list is any P over any Q. And you're going to get the plus and minuses there, and that's going to generate a list, and then we're going to test those numbers in the list until we get lucky and find a zero by getting a remainder of 0, sending it through synthetic division or either plugging it in as discussed on our last lecture. Okay, so here's an example. Can you see that okay? There's 2x cubed minus 3x squared minus 2x plus 3. So P here is 3. It's basically all of the factors of 3, and Q here is 2. And that's going to be all the factors. So what are the factors of 3? Plus or minus 1, plus or minus 3. So those are the things that would multiply to 3. And all the factors of Q are plus or minus 1 again, and plus or minus 2. So my list, any possible rational root, any solution that's going to be an integer and a fraction must be in this list. So for example, there's no way 5 will be a solution here because it's not going to be in that list. So let's just do plus or minus 1 over plus or minus 1, which is plus or minus 1, plus or minus 1 over plus or minus 2, which is plus or minus 1 half, plus or minus 3 over plus or minus 1, which is plus or minus 3, and plus or minus 3 over plus or minus 2, which is plus or minus 3 over 2. Now we're going to use synthetic division to try to find a root, and if we can find a root or a 0, we can reduce this to a quadratic and we can solve the whole thing. All right, so we try to give you numbers that are easy. We try not to let 3 halves be the 1. So always try 1 or negative 1 first, and then go to your next easiest, like 3 to negative 3. I can't speak for Math Excel, but anything that we give you as teachers, we're going to make sure you get your first root fairly easily. All right, so this gave you a hint to try 1. So I'm going to send 1, and that's x equal to 1. I'm going to send 1 through synthetic division. So cube, square, single, constant, bring the 2 down. 2 times 1 is 2. That combines to -1. -1 times -1 is -1. That's -3 times 1, -3. So perfect. We got a root. So I know that x minus 1 is a factor and x equal to 1 is a root. So now I'm going to rewrite my f of x as x minus 1. And remember, this is a quad. So this is 2x squared minus x minus 3. I can use quadratic formula. We're going to go ahead and solve it. And so this is going to be 2x. This is going to be x. We need different signs that will combine to get a -1. So it's going to work like so. -3 and plus 1. So mentally checking that. That's 2x squared. And then that's -3x and positive 2x, which is -x. And then a -3 in the end. So what are my zeros? They would be x equal to 1. I went through in arithmetic division. X equal to 3/2, and x equal to -1. So were all the numbers in the list? You bet. There's 3/2 and there's plus or minus 1. So yes, as they should be. You'll never find a 0 here that is not in this list. Now, you know, there may only be one rational root here, and the other one may have been plus or minus root 3. I don't know. You may have just one rational root here, and the others may have been imaginary. We don't know. But in this case, there were 3 rational roots, and they are certainly all in this list. All right. So next page here. One more problem. Find the real zeros of the polynomial without using your TI. How many zeros should we have? Well, could be 4 real zeros. It could be 4. So let's see how that looks. All right. So we're going to test. You know, this P over Q here. P here is 1 and Q here is 1. So my P over Q list here is pretty easy. Plus or minus 1. So it says to test 1, and it says to test -1. And so this problem is not using synthetic division. This problem is just showing us that remainder theorem that we can indeed, you know, see if we get a hit by plugging in. This just says to plug it in. So let's plug 1 in, and we get 1 plus 3 times 1 cubed. That's 1 to the 4th. That's just 1. Minus 2 times 1 squared minus 3 times 1 plus 1. So that's 1 plus 3 minus 2 minus 3 plus 1, which indeed is 0. So if f of 1 is equal to 0, then x equal to 1 is a solution, and x minus 1 is a factor. Okay? Solution, factor. Okay, let's test -1. I get -1 to the 4th plus 3 times -1 cubed minus 2 times -1 squared minus 3 times -1 plus 1. So that's 1 minus 3 minus 2 plus 3 plus 1. Okay, and so that is 0 also. So x equal to -1 is a solution, and x plus 1 is a factor. Okay, but what this did not do for us is this did not reduce me down to a quad to solve the other ones. So this is just reminding you that you can, you know, get a hit of a 0 by using this plug it in, but it doesn't really help you reveal the quadratic. So let's send 1 through 1, 3, -2, -3, 1 through synthetic division. 1, 1, 4, 4, 2, 2, -1, -1, 0. Awesome. So that's now a 3rd degree. Let's send -1 through that. 1, -1, 3, -3, -1, +1, 0. There's my quad. All right, so that is x squared plus 3x minus 1 equals 0. Okay, so that is basically x plus 1, x minus 1. I guess I should put those in the order I tested. Question came up in class on Friday. Does it matter who you test first? No, it does not. But I'll just put that in order because that's how I tested. And then I've got x squared plus 3x minus 1, which does not factor. It's going to require the quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a x equals 3. That's right, negative 3. Let me write that a little better. X equals negative 3 plus or minus root 13 over 2. So we got 4. Notice since we started with a to the fourth, we got 4 answers. We got x equals to plus or minus 1. Both of those were in the rational roots list. And then from the quadratic formula, we got negative 3 plus or minus root 3 over 2. That is not a rational root, so it wasn't in the list, but it is still a solution. So summarize what we know here. They're at most n distinct real zeros. So 4, we could have had 4 here, and indeed we did. This is not rational, but it's real. We want to use the rational root theorem to list all possible rational roots. So that's your, plus or minus p over q. You're going to want to use synthetic division. Or the remainder theorem, which is substitution. Plug it in to test for zeros. So you're looking for a remainder of 0 here, or substitution to test for zeros. Remember, at step 3, you're for r equal to 0. Whether you plug it in. Once the polynomial is factored to conclude a quadratic formula, a quadratic function, then use the quadratic formula, QF here, or I guess this should be QF here, quadratic formula, or factoring, okay? So I'm just going to use ZPP, which is factoring, or use the quadratic formula, and that's factoring. Okay, and that will be that'll get you all the solutions that you need, unless they're imaginary, which is what is going to happen in 4.3. All right, guys, happy Monday. We will see you in class. Take care.